Pleasant morning to one and all. I, Rakshita,
I, Samra,
of BSc, feel privileged to welcome our correspondent sister Shyamala, Principal Sister Amy, Head of the Department by Hemlata Ma'am, and all the faculty and all my dear friends to this Spark session, Mindful Math. You know, Samra, I was a topper in math in school.
Oh, really?
What about you, Samra?
I'm scared of math.
Ah, okay. Let's see if your perspective can be changed by our first team.
So, give a round of applause to our team, Feed Me 5. Participant names A. Madhurima, G. Shivani, Salonika, B. Laukya, and Mariam Naz.
Good morning everyone, I am Mariam Naz from BSc Stats 3. Our team name is Feed Me 5 and the team members are Salonika, Shivani, Madhurima, Lokya. We came up with the dress code white because how salt is important in our food and the same way math is also important in our daily life. Before we get into the topic, does anyone know what is culinary? Anyone? Yes. Culinary is a food in kitchen or a cooking item. Does anyone know we actually use maths in our kitchen? So our topic is culinary food. Mathematics is from Asian subject is known as math. We can find a math in everywhere and everything. This presentation will show us how math is being used in our daily life. To continue this topic, I hand over the session to Salonika.
So we all know that math is very important in our daily life. We tend to use it more, frequently we use it. So firstly we'll go step by step, remembering our childhood days, where firstly we'll go with the childhood days, where we begin to make our first real life connections to numbers. In our childhood days, we all consumed ice cream, where we all tend to recognize its shape, cone or something like that. So in that also maths is included. So in that, so it made us to get a grip on shapes, numbers. When it comes to adulthood, let's take an example of a mothers. They use it more like maths when it comes to our mothers, and even chefs. Mm. And even our old age, they learn to balance their diet and to be disease free when it comes to symmetry in food items. Kiwi. If we observe the pattern of the seeds, there is a gap between the seed, and it has a symmetrical shape when it comes to apple. And apple doesn't have any perfect symmetrical shape. Every apple has a different symmetrical shape. If we cut it in a horizontal way, it has a different symmetry, and it in a vertical shape, it has different symmetry. And even in a pineapple symmetry, pineapple is a fruit when it all has parts symmetrical included, even in leaves and the inner parts we have symmetrical lines. And now I hand over the mic to Shiva.
So the next topic is balanced diet. On an average, a human's personal diet should include 70% of carbohydrates, including vitamins and minerals, in a smaller quantity, and 30% of proteins. To achieve this, the applied math that we use is fractions. The 3 by 4th and 1 by 4th rule is about a balanced meal that should include 3 by 4th of carbohydrates, whose source is whole grains, and also including fruits and vegetables. The 1 by 4th of protein from meat and other sources. So we hope everyone follows 3 by 4th and 1 by 4th law to have a balanced diet. So the next topic is food packaging. Has anyone ever heard of squared watermelons? Squared watermelons or cube-shaped watermelons are harvested by Japanese farmers. The purpose of the square-shaped watermelons is to save space in storage and to avoid the rolling of watermelons while cutting, which you can see on the right side of the slide. While growing these watermelons, the farmers place these watermelons into square-shaped molds to give it a cubical shape, which you can see on the left side of the slide. So here we use geometry and mensuration. Now I hand over the session to Madhurima.
The next topic is pie in pizza. Does anyone know how we got the name pizza to pizza? So as we all know, pizza is made in the shape of circle. So let us assume the radius of a pizza as z and the height of a pizza as a. In general, the volume of the circle is pi r square. Now we substitute the radius z and the height a in the formula pi r square. So we get pi z square a. So pi into z into a, which makes the word pizza. So do you know why pizza is cut into triangles? Pizza is cut into triangle slices so that every slice get an equal portion of toppings and crust. Why not square them? We can cut in squares, but we don't get the equal portions of toppings and crust, right? So we cut in triangles. So the next topic is temperature and time. Temperature and time in the oven are dependent on each other. When we change the temperature, automatically we need to change the time as well. If the temperature is increased, the time should be decreased. If we take the example of baking the cookies, for example, we take the baking of cookies. In that, if we increase the temperature, we need to decrease the time, and we need to if we decrease the temperature, we need to increase the time, and vice versa. Fractions and division. Fractions and divisions are necessary for measuring and serving sizes. For example, if a baking recipe which was meant to serve 12 people and you need to serve only 6 people, the baker would have to use fractions to divide the amount of serving. Next one is ratios. Ratios are calculated by weight and volume or through mixed methods. For example, ratios by weight include bread dough. For making bread dough, we use flour and water. For volume, we include sugar syrup. To make sugar syrup, we use equal parts of water and sugar. Now I hand over the session to Laukya.
We conclude that mathematics is an integral part of cooking. It is necessary for our taste and healthy appetite. Mathematics goes behind the real world, but the real world is the rule by it. Thank you.
So, Samra, are you hungry? Or did your perspective change on math?
I'm not hungry, but I'm still scared of maths.
Oh, still? Okay, let's call upon our next team, Pyramid Scheme.
And the participants are Namreen, Bhargavi, Maunya, Dharani, and Meena.
Give them a round of applause.
Good morning, everyone. Our team name is Pyramid Scheme. First of all, I would like to introduce myself. I, Dharani, from BSc Third Year Electronics, and my team members are Namreen, Maunya, Bhargavi, and Meena. Today, we are here to give a presentation on maths around us. Mathematics is all around us. We can see maths everywhere in the nature, like the beauty of the flower or the rocks we walk on can also exhibit the nature sense of symmetry. And we have the concepts of geometrical shapes, symmetry, Fibonacci spiral, the golden ratio and fractals. My topic is about geometrical shapes. Here I have an example of cones. You can see a picture there, volcanoes. There are the different types of mountains. The burst of lava and the ash flows down. Even after that, they form like a cone. And other example is parallel lines. We know that parallel lines have no end. We have an example in our nature too, even the blackboard and railway tracks, roads, etc. So these are few examples of parallel lines. Now I would like to hand over the session to Namreen.
So, good morning everyone. Now my topic is symmetry. So, I think everyone know what is symmetry is. So, the meaning itself tells that it is when a figure has two sides, the mirror image of another is the symmetry. Like if you draw a line between a shape, the two sides will be same. The two figures will be same. As you see in the figure, the A has two symmetries. If example, if I give you a task to draw a heart, what you will do? First you will fold a heart, then you will draw a heart shape in a half way. Then you will cut it and then you will open it as a full. So the line is called as line of symmetry and this is the symmetry definition according to the mathematics. So in this we have two types of symmetries, namely bilateral and radial symmetry. According to the nature, we took this topic as bilateral and we have so many symmetry types in this. So as first when I told this is a bilateral symmetry, in this the symmetry is divided into only two halves. Whether whatever shape it may be, it is divided into only two halves. For example, we'll take as a human body. If we draw a line between like from top to bottom, the line of symmetry, we'll get the two equal parts both sides, left and right. So this is the bilateral symmetry. So we have some examples, like you can see that butterfly. You can mention, like you can see it as a line of symmetry in the middle, and that is the two equal halves. And you can see some daily use, like daily we see in the environment, like trees and birds and etc. The glass of water and the specks are also comes under bilateral symmetry. We have so many geometry shapes like squares, rectangle, and etc. So many. So now the second type is radial symmetry. It is somewhat different. Like radial symmetry, if we can divide into so many, more than two equal shapes. For example, we can take as a starfish. We can divide it into 5 parts, or we can take pizza also. So you may have seen the different sizes. Like all sizes are equal in it if we divide it. So these are some example figures. So we can see flower, which are divided into equal parts. You can see here 4 different parts, here 4, but both are equal. And this radial symmetry in starfish, you can see 5 different parts in this. So I hand over this session to Meena. Thank you.
Good morning, everyone. My topic is Fibonacci spiral. If you construct a series of squares with lengths equal to the Fibonacci number 1, 1, 2, 3, 5, etc., and trace a line through the diagonals of each square, many examples of Fibonacci spirals can be seen in nature. The Fibonacci sequence can be found in pineapples and bananas. Pineapple states have Fibonacci spirals in sets of 8, 13, and 21. Just above every plant or animal are governed by Fibonacci sequence. All the numbers are Fibonacci numbers. Thank you. Now I hand over the session to Bhargavi.
Good morning everyone. My topic is golden ratio. Golden ratio is a mathematical ratio commonly found in nature and it is represented by Greek letter pi. As we all know about pi, but here pi value is 1 point.
316. The golden ratio is sometimes called divine proportion because of its frequency in natural world. Let's take the examples. Here we are taking two examples. First example, seashell. The half rotation of 180 degrees to expand the width of spiral to 1.618. The golden ratio continues another half turn of 180 degrees to complete 360. The complete full rotation 360. The width of spiral from center is now 2.618, which is the square of golden ratio. And another example is wild rose. Wild rose have 5 petals arranged horizontally. If you take the mathematical relationship of adjacent rose petals, then divide it, then you will get to 1.618 or 5. Thank you. Next I hand over section to Maurya.
And now I am here to tell about factors. We can see factors in our daily life like branches of trees, electricity, plants, lightning, animal circulatory system, etc. And this is a picture of Sierpinski triangle. In this picture represents about the fundamental principles of factors. Many equilateral triangles can form this Sierpinski triangle. It can repeat patterns again and again. Next. And we conclude that maths is everywhere in this world. We enjoy nature and not interested in going deep about mathematical ideas in it. It expresses itself everywhere in our daily life and nature around us. Thank you.
Thank you, team Pyramid Scheme. So, Samra.
No stop. I'm still scared of math.
Let's see. Now we call upon our next team.
Put your hands together to our next team, quadratic questions. And the participants are Pravina Krishna, Ashrita, Anusha, Yashashwini, and Sai Satyateja.
Avantika.
Morning everyone. I am Avantika from PLC final year. We the team quadratic questions. Our team members are I Avantika, Pravina Krishna, Ashrita, Yashashwini Mani. Today's presentation is about FLP holes. In this section, we'll get to know what is algebra and in real life where we'll use FLP whole square formula. I am sure that you will feel enriched with knowledge after completion of this presentation. Now, I hand over the sections to Ashu.
Good morning. Can anyone see what is algebra? Not textbook definition. Can anyone? Just simple definition, not textbook definition. Okay, I'll say. Algebra is a union of breaking words. Like we'll reunion the words into broken parts like A, B. We'll use A plus B whole square. The single letters we are combining combining of variables is called algebra. Okay, now we'll come to the actual definition of algebra. It is a branch of mathematics that deals with the symbols and arithmetic operations that across these symbols. What are variables? Yeah. Variables we use alphabets, right? In mostly algebra we'll use X, Y, Z, O, P or Q, right? Mostly we'll come across with the X and Y, right? Yeah. In school days we equation will use algebra, right? Next.
Okay, everybody here knows what is a plus b whole square, right? We are learning it from like 6th class, right? So since like I don't know how many of you have experienced this question, like everybody like after learning this formula, they used to ask me, not only me, general question was, where will we use this a plus b whole square? Why do we need to learn this a plus b whole square? And how is it useful in our real life, right? I have experienced this. I don't know how many of you experienced it. So here we are to explain what is a plus b whole square and the definition of it, like what is it a plus b whole square and where we use this a plus b whole square in our real life. So I now hand over the session to Ashrita.
Yeah, you can see the image, right? Figure a plus b whole square. The parts are divided into a square, ab and b square. And as I already told, reunion of these a square and b square. It is mostly used as binomial factorization. Okay, it is the square of binomial and it is used as the sum of the two terms. In real life, where we'll use this a plus b whole square? Can anyone? Not in math, not for marks. In real life, where we use this formula? This will be explained by Yashashri.
Yeah, so in real life example, we know now we get to know where we use a plus b whole square. So many in real example villages where we have people have land. So how land is actually the size of land is basically mentioned as squares, like 5 squares, 10 squares examples. So because dividing into squares, the calculation part is very simple. So suppose when you have to decide how much fertilizer you have to use for your land. So example, I have 5 squares of land. So I'll be dividing the land into 5 rows and 5 columns. So how many small squares I am having? How many? 25. So 25 is nothing but 5 square. Yeah. So if each small square uses 1 packet of fertilizer, so I need 25 packets of fertilizers. So this is where we will be using a plus b whole square. So coming to a plus b, so consider a line which is divided into 2 parts. The pink one is A and blue one is B. Next slide. So whole line is a plus b. Whole line is a plus b because we divided into 2. Coming, so the square, so a plus b, a plus b, a plus b and a plus b. So the inner square is a square. This is the square, and after coming here, this is a and b. So it is a rectangle. Area of rectangle a into b. So it's ab here, a square, and here again a, b and b. So it is here again rectangle. It is area of rectangle a into b. So it is ab. Here we are left with only b and b. So here it is b square. Next slide. So the size is nothing but the summation of inner squares, right? So it is nothing but a square plus b square plus a plus b, which is nothing but a square plus 2ab plus b square. So I think you understood the real life example of this. Now I will hand over this to Pravina for conclusion. Thank you.
So mathematics is not about numbers, equations and algorithms. It's all about the way you understand. If you understand the concept, you can really use it in real life, right? Whatever you learn here is, like most of you think, it's not useful in our future, but you have to understand where it is used. So thank you so much. Thank you, Team Quadratic Questers.
Now, put your hands together for our next team, Math Survivor team. And the participants are P. Harita, P. Sarita, P. Shweta, and P. Pravanita.
A pleasant morning to correspondent Sister Shyamala, respected Sister Emmy, beloved lecturers and my dear Anites. I, Shweta, and my teammates are Sarita, Harita and Pravalika from BSc 3, belong to a team Math Survivors. Now we are here to present the PPT on a topic called Math in Real Life. Some common views of mathematics. We all think that maths is very hard, maths is boring, maths has nothing to do with real life. But we are here to show you how maths is important in our real life. Let us consider an example of use of functions in our dating days. These functions are from mathematics, which is a part of your dating days. You want to know how is this possible? When you are following a diet, then you measure your weight very frequently, almost like every day. In that case, you are seeing your weight as a function of time, as the function is nothing but mapping between two conditions. Now let us consider another example by Sarita.
Let us consider another example of geometric in fashion design. Geometric includes the study of the properties of various shapes, and fashion designing is an art which can make all the shapes in a beautiful way. Fashion designing industry is making use of it very efficiently and beautifully. Next, let us see another example. Another example is use of trigonometry in flying fighter jet. As we are aware of trigonometry, when we study trigonometry chapter, we come across many problems dealing with what is the flight height and from the ground when it is observed in a particular angle. This happens in the battleground also. The trigonometry helps the trace of the path at a certain angle. Now let's see another case.
Let's see another example. In this case, the burglar robs a bank and escapes in a gateway by car. He was chased by police. Good news is that police takes a photo, and bad news, the photo is blurred. Then the solution is take that photo to the mathematician. He will give a formula to you. Blurring convolution, it is by using Gaussian's law. We can get rid of that blur. We can get a clear image of the blur. So by now you know a lot of uses of higher mathematics in our real life. Now if anyone asks you at this level what is the use of mathematics, you can say these examples to them. Now I like to conclude by saying a wonderful quote. Life is like a math. If it goes too easy, something is fishy. Thank you.
Thank you, team Math Survivor. Now, let's call upon our next team, the Masked Bull. And the participants are Jennifer, Anupama, Maithili, and Samira. Give them a round of applause.
A very good afternoon to everyone present here. We are a team of 4. My team members are Anu, Maithili, Samira and myself Jennifer. So me and Anu will be talking about math in general and Sam and Maithili will be talking about math in animal patterns. To start this session, I would like to ask you guys a question. Do you all know what the painful part of mathematics is? Okay, I'll tell you the answer. To start off, it starts off like a very cute subject. Like you add 1 plus 1 equals to 2, 2 plus 2 equals to 4. And then it keeps escalating escalating and escalating and escalating till at one point there are no numbers left in the math subject. For example, a square plus b square is equals to c square. You won't find any numbers there. So one day in my second class, my math ma'am drew a line on the board. My math ma'am drew a line on the board and wrote 1, 2, 3, 4, 5 on the line. I was like, yes ma'am, I understand this. This is number line. And then she was like, do you know what is between 1 and 2? I was like, nothing. So ma'am was like, okay, if there is nothing, let's add something. She wrote 1.1, 1.2, 1.3 till 1.9 till now, for now. And then she was like, do you know what these numbers are? So I was like, yes ma'am, I understand this. So ma'am told me, Jennifer, you understand this because you are a rational person and these are rational numbers. So basically what she was trying to tell is, irrational numbers are like irrational people. After a certain point, they keep on talking and talking and talking, and the same thing are with irrational numbers. After a decimal point, the numbers keeps on going and on and on and on. So now comes the geometry. For this, your normal pencil box won't work. For this, you need a steel box called geometry box. When you open this, the first thing you see in the geometry box is compass. So the compass is basically a crutch for a physically handicapped pencil. It holds it and goes and round and round. And the next is set squares. Set squares is a set of triangles, dude. Set squares is a set of triangles which are used for measuring the angles. And then you have a divider. Divider, for a long time I didn't know what it was used for. And by the time I got to know what it was used for, geometry box was not needed anymore. Now I would like to hand over the session to Anupama.
One day my maths teacher came in with a black ball and she told us there are 3 black balls, 2 yellow balls and 1 red ball. She puts her hand inside and she said, how will you tell which color ball I am holding? And I was like, ma'am, it's only possible with black magic. And she was like, no Anupama, it's probability. After that, I felt like even the numbers were scared like will not roam separately, will all go in progression like arithmetic and geometric series. All these went on till they fell into a formula and this new thing called calculus came, where even the numbers were like, we'll find another subject, you guys do whatever you want. By this time, all the numbers disappeared. All the remainings were dy by dx, x, y, etc. And in between, this new thing came called integrals. They are like huge snakes in between. Here in integrals, questions are also in equations and answers are like in big equations. Now I would like to hand over the session to Sami.
Good morning everyone. So I'm going to talk about math in animal pattern. Many animals have stripes or patterns for purpose of camouflage. But why particular design? Hardcore research believe they know how a certain directions occur and they have come up with statistical model. Animal stripes appear when interacting substances creates wave of high and low concentration of substances. This can be result of continuous pattern line forming. For example, while a tiger has a parallel stripes evenly spaced and perpendicular to the spine, has been going since 1950. For example, was looked at by father of computing, Alan Turing, a line of inquiry that led to turning reaction diffusion model. It has taken nearly 60 years for the explanatory equation of the production. One part of the model looks at why stripes are oriented in a particular direction. For example, why the stripes of tiger are perpendicular to its body and why those zebra and fisher stripes are horizontal. The model predicts 3 main factors that affect how stripes orient these are. The production gradient, a term of substance that amplifies stripe pattern density. The parameter gradient, which describes a substance that changes one of the parameters involved in forming the stripe. A physical change to the molecular, cellular or mechanical origin of the stripe. Now I would like to hand over the session to Maithili.
So continuing with math in animal patterns, I would like to talk about Alan Turing. It has been 60 years, Enigma codebreaker Alan Turing came up with a theory for why ribbon has its stripes. Do you know why? As the stem cell research proves him right, we look at how patterns in nature can be explained by mathematics. We can see as a visual in the screen hotspots of a spotted, speckled and straight leopard spell finds a means of applying order to the shapes through mathematics. The apparent randomness of patterns that appear in nature, a zebra zigzagging stripe or labyrinthine mosaic of giraffe skin, are accepted without a question by most of us. In 1952, Turing published a groundbreaking paper called The Chemical Basis of Morphogenesis, containing an elegant mathematical scheme for the formation of patterns found in animals and plants. The patterns were from random. He argued that were the result of interacting chemicals and spread among the group's otherwise individual cells. He coined the term morphogen, meaning shape formers. Thank you.
Thank you, team. The masked wolves. Samra, are you still really scared of math?
No, I think math can be fun.
Perspective is changing, I guess.
Enough of my math texting. Let's have fun with the audience.
It's time for Math O'Clock.
How many sides does a circle have?
Think.
Okay, I repeat. How many sides does a circle have?
The answer is 2. Inside and outside.
What do mathematics teachers like to eat? Yes, the correct answer is pie.
What does one math book say to another? I repeat, what does one math book say to another?
Yes, the correct answer is I have so many problems. Help me to find my friend. He is an odd number, but if you take away an alphabet from him, he becomes even. Who is he? I repeat, he is an odd number, but if you take away an alphabet from him, he becomes even. 7. Yes, the correct answer is 7.
Hope you all enjoyed Math O'Clock.
Yes.
Now, put your hands together to welcome our next team, Calculus Hero.
And the participants are Preeti Susan, Nancy, Shirisha, Sneha, and Chandana.
Okay, now let's call upon our next team, Drink and Derive team.
And the participants are Harita, Gayatri, Shazia, Shravanti, and Srijana.
A pleasant morning to everyone. I am Srijana and my teammates are Shravanti, Harita, Sajya and Gayatri. Today our teammates is here to share you some information about math in nature. There was a famous saying by Euclid: the nature of art, the law of nature are but the mathematical thoughts of God. Mathematics is all around us. As we discover more and more about our environment and our surroundings, we see that nature can be described mathematically. The beauty of flowers, the majesty of a tree, even the rocks upon we, which we walk can exhibit nature's of sense of symmetry. Although there are other examples to be found in crystallography or even at a microscope level in nature. Now I hand over the session to Saju.
In nature, we can find maths like geometrical shapes, Fibonacci spiral, golden ratio, and etc. So, I would like to share you that geometrical shapes like polyhedra, cones, parallel lines, and etc. are found in nature. Polyhedra is a 3D shape with flat polygonal faces, straight edges, and sharp corners or vertices. Examples of polyhedra include cube, prism, or pyramid. And cones, there are also 3D geometric shapes that taper smoothly from a flat base to a point called the apex or vertex. Example, ice cream cone. Parallel lines. There are coplanar straight lines that do not intersect at any point. Example, rails of a ladder. Fibonacci spiral. Fibonacci spiral go from galaxy to sunflowers in nature. Fibonacci sequence or series is a series of numbers in which a given number is the addition of the two numbers before it. Every number in this series is obtained by adding the two preceding numbers. This simple series is referred to as Fibonacci sequence or series. We can find out the Fibonacci series at any point by using the formula f of n is equals to f of n minus 1 plus f of n minus 2, where n is greater than 1. Now I hand over the session to Shravani.
Good morning, everyone. Let us discuss about symmetry. Already our seniors discussed about symmetry. Can anyone say what is symmetry? We already discussed it. Okay, in our childhood, we used to have some drawing books where there used to be a line in the middle on the left or right side. We used to have some pictures with half of the diagram used to be there, and we used to draw on the other side which was left empty. There we used to use symmetry. Let us discuss a general definition. What is symmetry? Symmetry is a property of an object, where symmetry is nothing but if we take an object and if we draw a line of symmetry, then one shape is going to be exactly like another when we move it, like when we flip or when we fold or when we even reflect it. Then let us discuss some examples. There are many types of symmetries, but because we are discussing only about nature, let us discuss only three types. There are bilateral, radial, and spherical symmetries. Bilateral symmetry, if we use only one symmetrical line where we divide an object into just two parts. Best examples of bilateral symmetry are moths and butterflies. Even scientists declare that even our human beings are examples for bilateral symmetry. And next, radial symmetry. An object can be divided equally about a central point, like pie, cut in equal parts. And best examples are stars. Even some flowers we can do radial symmetry to some flowers. And the last but not the least is spherical symmetry. Let us take sun. We can draw many symmetrical lines, but not best examples are ball, full moon day, not moon. On full moon day, we can find a good sphere, so we can do spherical symmetry with that. Now I hand over the session to Shazia.
So fractals. These fractals are infinitely complex patterns that are self-similar across different scales. They are created by repeating a similar process over and over in an ongoing feedback loop. Driven by recursion, fractals are images of dynamic systems, the pictures of chaos. Example, in this flower we can see petals are over and over with different sizes. Now I hand over the session to Harita for conclusion.
Now, as they said about symmetries and fractals and etc., maths is everywhere in the nature. So we can find many things in the nature. Not only these, we have many examples. So can say that maths is everywhere in the nature. Thank you.
Thank you, Drink and be right.
Now, let's call upon our next team, Pirates, and the contestants are Rishika, Vaishnavi, M. Jahnavi, Sai Keetana, and Maleshwari.
Good morning everyone, my name is Sai Keetana from BSc second year Stats, and here are my fellow mates Rishika, Maleshwari, Jahnavi and Vaishnavi. And you people can see that we are in a yellow dress code and it resembles about positivity. We are as we think that we think maths as a positive thing, and we are thinking that you should take maths as a positive subject and don't think it is full of problems. I say that maths is not full of problems. Without maths, our life will be full of problems. Now I am going to explain how maths is involved in some scenario. Now let us see this picture. Now what you'll observe? Can anyone say anything which is involved maths in this picture? Yes, there are many. You can see in leaf also we have some maths, and the shape of the trees, there is symmetry. So many things. Just I am taking one example. I am just taking a leaf. So from here I am explaining about a simple maths topic. As we can see in leaf, it has only one central structure and many origins, and again it is divided into small branches. In the same way, from this we will get a small topic which we learnt in our childhood. It is prime factorization. As we only as I am comparing the main number as a central structure, that is 144, and the divided part, the means as it factors 72 into 2, like that another branches will get, and the last are prime numbers. So this is prime factorization. So I hope you learned something from me. Now I am handing this session to N. Jahnavi.
I want to relate maths to solar system. We all go to amusement parks, right? There we can see lot of rides, and one of them is roller coaster. Basic topic involved in roller coasters are measurement, calculus, trigonometry and geometry. So coming to measurement, it is nothing but measuring something. So we measure length, height, weight, area and volume. We can see that in our daily life we measure a lot of things. Coming to this, in roller coaster we measure stress, the speed of the coaster, the weight it can hold, and mass is calculated to how roller coaster will be affected by gravity, mass, acceleration and kinetic force. So we all know these terms are from physics, but to calculate those terms math is involved. calculus, basic mathematical subjects such as calculus, to allow the car to get up the next hill, the mass speed and the angles of ascent and descent. These calculations also make sure that roller coaster is safe or not. Coming to trigonometry, trigonometry allows designers to see how steep and long its descent will be from a given height over a given distance. This allows them to alter the height and length of descent exactly to produce the maximum thrill. Geometry. Triangles in comparison to squares and circles are proven to the studiers of the shapes. The tracks of a roller coaster must be strong in order to withstand the immense amount of pressure exerted by them on ride after ride. Building a roller coaster requires a large amount of math. First off, designers must know the maximum velocity of train without it going off the track. I'll hand over this session to Rishika.
My topic is maths involved in shopping and tourism. Better to say maths involved in shopping. Shopping is also involved in maths. Okay. Shopping is the most interesting topic in everyone's life. Okay. You use counting and addition used in order for buying anything what we do in shopping. For shopping, mainly girls will look for discounts, offers and any buy one get one offer, right? In that also maths is included, right? Without knowing how much percentage and discount you are getting, you will be completely you will get lost. Your shopping does not include the discount. Percentage and additions are used to calculate the bills. In billing section, the maths is included in high level. We can see in shopping malls, right? Then subtraction is all in order to figure out how much change is due. After billing, how much money you are getting after completing your billing. Maths involved in tourism. Traveling is most interesting and exciting. Budget. When we are traveling, main thing we have to look about the budget, right? Without calculating how much expenditure you are investing, it is waste of money. First, when we are traveling, we have to check budget and how much distance you are traveling, time, and main load that can be carried. If you are traveling in airways, you have a rule of carrying luggage in limited way. If your luggage is excess, the airlines would not allow to travel. So by this I'm saying that when you are traveling, budget and calculating fuel and requirements for the motor vehicle and calculating the distance and time taken and load that you are carried is important. Now I'm Malisha.
Good afternoon everyone. I am here to explain about the topic cricket. How many of you watch cricket? Do you all know that cricket involves mathematics? Okay, I will explain about it. Cricket involves mathematics. Mathematics play an important role in cricket. I think most mathematics is used in cricket only. Counting of runs. We all know that runs we count by score. Speed of the ball is measured. Decided length of pitch and area of the ground. It also involves, we also know that we can see the position of the batsman. We can say that the distance between batsman and bowler. We can also calculate the distance speed according to the batsman and bowler. The speed of the ball is the speed of the ball is also related to the mathematics. The average of a batsman is known by taking the mean sum of all his overall batting scores in his career. The strike rate of a batsman is determined by calculating a ratio of runs to balls faced. The bowling speed of a bowler is measured by maths. Now I'll hand over this session to Kalpan.
Good afternoon everyone. I'm Vaishnavi and I'm explaining about the topic maths involved in construction and interior design. Everyone has a passion to live in a well-designed house, villas, etc. Right? For constructing that, maths is involved in it. Before constructing, architect has to design it. Geometry, algebra, and trigonometry plays crucial role in it. Architects apply this math to plan their blueprints, initial sketch, design. They also calculate probability of issues the construction team could run into as they bring the design vision into life in 3 dimensions. Calculating ratio is essential when it's time to construct a building. For example, it's important to get the proportion between height and length of a roof, and we use Pythagoras theorem in constructing. It helps us in finding the size and shape of the structure. This also enables builders to accurately measure right angles. Coming to interior design and coming to maths involved in interior designing, golden ratio is a mathematical ratio you can find almost anywhere like nature, architecture, painting, music, etc. When especially applied to design, it creates an organic, balanced and pleasing composition. It is also known as golden section, golden mean, or the Greek letter pi, and the value of pi is 1.618. Golden ratio of a room can refer to its proposition like height, width, length, which is often used to ensure visual balance. Now the question comes, how does this relate to design? This formula can help us creating shapes, logos, layouts and more. Some of the ways to apply it is the golden ratio for color scheming, the golden ratio to introduce pattern, to get balanced room layout, for choosing furniture, for displaying accessories, for hanging art. Finally, I want to conclude this by saying a good understanding of maths in everyday life is essential for making sense of all members and problems life through adults. It's almost impossible to get through a day without using maths in some way because our world is full of numbers to handle and problems to solve. Hope you all enjoyed it. Thank you for giving us this opportunity.
Thank you, Team Pirates.
Last but not the least, let's welcome Team Executor.
Give them a round of applause. And the participants are A.S. Vaishnavi, A. Sneha, T.H. Sirisha, G. Vaishnavi, and P. Sirisha.
And not present here. First, I would like to introduce myself. My name is Sirisha from BSc Electronics 3rd year. My teammates are Vaishnavi, G. Vaishnavi, Sneha, and P. Sirisha. Our topic is, you will know it later. Now, we will take you on the train of journey from your kindergarten days to the present day. So, let's start from your kindergarten days, LKG and UKG. Imagine that you are right now in LKG and just now you are stepping in the school for the first time. You refuse to go at first, but after 2-3 times being scolded, you go to school with tears in your eyes. Your first class would be of mathematics. The teacher would teach you numbers from 1 to 10. They tell you to practice counting using your fingers. In the language classes, you learn the same, how to write the numbers in different languages. You do likewise. At the end of the day, you learn how to write number names in all the languages. Now after some time, your learning capability increases. You go to school by your own. You made friends and everything is pretty much sorted. Now the level of the math also increases. They tell you to learn numbers from 1 to 100. That too in all languages along with names. Level of work has increased. You learn them somehow. But it's really useful, right? Because wherever we go, we need to know how to count numbers to count items or stuff. Even a beggar knows this simple math by counting the coins he collects in the day. So the result of learned counting is helpful.
Now first to 5th class. Now have advanced from UKG to 1st class. You are excited to start the day of your school. You go and sit in the class waiting for the teachers to come. As how your class will start the math session. Now the teachers will start the Indian system teaching to international system. Then along with that, coming in the queue, you will come across the new word of math. That is addition and subtraction, multiplication, division, fractions. These are how they will be helpful in our 1st to 5th we will see. Addition for adding your pocket money for snacks, buying for snacks, and the subtraction also same. Multiplication for multiplying the amount with the number of friends. Division for dividing your share of pizza into half or whatever ratio.
Good afternoon everyone. My topic, secondary school. You have reached the stage of writing with a pens on your notebooks, feeling excited of using your new gel pens. Now your past notes also have advised from rule to unrolled notebooks. You will learn different topics like rational, irrational numbers, integers using graph paper, plot paper, graphs. And most interesting thing was to use protractor to measure the angles. Am I right? You all have done that. But the most surprising element which we will later come across is finding the value of x. The most ridiculous question till now is finding the value of x. Did you feel so? Yes. What is the purpose of it? The word problem, area and perimeter of shapes are in. At a point of time, there was a more English in the math than the math in the math. Sound like a riddle, right? Now tell me, did you really use all this knowledge in your real life anytime? So the result of learning this is unknown. Thank you.
To D. Now you have reached the crucial stage of life, that is 10th class. Everyone in the neighborhood is ready to wait to come to know your result, as if it is a national news for them. All the pressure from all the sides mostly focus on the mathematics marks. When you look into the textbook of mathematics, it is on another level. And there is another version of the textbook. If you remember correctly, it is R.T. Sharma's book. It is totally a different universe itself. When you closely look into the chapters, first thing, you might be very scared about how to pass this subject. There are new topics called trigonometric ratios, and progressions, angles on triangles, sets, etc. Before you had to find only x value. Now it's x, y and z. Somehow you crossed the matrices exams. Now you are on the stage, decision making stage. When you go for commerce side or science side. Now out of parental pressure or your choice, you choose MPC. In the inter, we had 2 mathematics books as if one was not enough. In those books, there are again completely new topics like matrices, limits, continuity, locus and hyperbolic functions, etc.
Those chapters were somehow manageable, but integration and differentiations, these two chapters with the most weightage of the marks, tortured you on another level. Because there were so many formulas to practice. After passing both of the years successfully, you are again standing on the decision-making path. Either go straight to the science field or take U-turn to the commerce field. If you choose BSc in the degree also, your story is still going on with the syllabus. Differentiation is Differentiation is updated to partial differentiation and integration, limits and continuity still not left us. So in the end of the day, we need to, we, so at the end of the day, we need to take all these topics to use in our real life. The result of learning all these topics in this level is still unknown.
So why, right? We are stuck in this question, why? In 10th class, you had so many chapters, right? So many, mathematics, areas and perimeters. And areas, there are so many formulas, total surface area, lateral surface area, curved surface area. Tell me if I missed anyone. Right? So many were there, right? And we had to pass 10th anyhow. Because mostly everyone was focused on our 10th marks, right? So we passed anyhow. Now coming to the inter, again we had same number of formulae, updated version, right? Updated chapters, integration and differentiation. They were like monsters. What is the second formula in the integration? No one knows. Have we ever learned the formula in a serial order? Never, right? We see the sum and then accordingly we put the formula, right? So same, again in degree also, same story. Boring story, right? How many of you find math very hard? Be honest, okay? I will see the marks of yours. I will ask the lecturers. This side is very intelligent, they're great mathematicians. Greatest mathematicians. Very great mathematicians. Raise your hands, be honest. You both are toppers, I guess. I will check your marks later. Okay, fine. Now you find math hard, right? And you might be thinking, why integration, why differentiation, why this whole stuff? Because we don't use it in our real life, right? Where do we use integration in real life? Do we find anywhere and just, oh, this formula is used here, so we will use it here now. Then what about the commerce people then? They don't know integration, right? So, you had choice when you were in inter. Either go for commerce or for MPC or BIPC or whatever, right? Now, okay, fine, your subject is you are weak in math, but you are very strong in science. So you go for MPC, right? Now tell me, in physics you had, there were no math in that? There was, if you remember it correctly, RMS, to derive RMS, you used integration and limits and continuity, right? 2 pi, pi to 2 pi, like that we had put an integration and we had then got the value. In chemistry also we use math, same math, right? Now tell me, when we, your inter, okay fine, out of your parental pressure you have chosen MPC or okay your own choice. But again you have a choice after inter, right? Degree or commerce. You chose degree now. Again we have two fields, electronics and statistics. In electronics, we again use the integration and differentiation. We have circuits also, integrator and differentiator. They work on the principles of integration and differentiation. And there are other circuits also where we use math actually. So, do you still think that math is not useful? Yeah, still not useful, huh? Very useful. Okay, basic math is useful, right? Basic math, counting, addition and all. You cannot completely strike it off and say that math is not useful. You can say that. No one can dare to say that. Why, I will tell you. If there is an uneducated person, they don't know science at all. They don't know what is digestion, excretion and all that. What are the parts of flower. I still don't remember the parts of flower, though I am taught in science. Right? Okay. So they don't know anything about science. But can they really survive in this, situation? Life? Can they? Yes? Why? Because they have math. They know math, right? Counting, addition, multiplication, subtraction, these are enough to survive. You don't need to know digestion. If you know digestion, then only the digestion system is working. Right? So, without knowing science also, by knowing math you can survive. Without math you cannot survive. Right? So, even science also, math goes in hand by hand with science. Without math, science is nowhere. Even if you're interested to go for NASA also, need to know many formulas. And to derive those formulas, you need math. Simple equation. So you can't say that you hate math or math is not useful. I dare you to say that again. Okay? Now, you say math is very hard. It's not easy. So we have solutions for this math. In life, we don't know what is the solution for our problem. But in math, at least we know the answer, right? In the last page. So if we put the correct formula, then you will definitely get the correct answer. The way should be correct, right? The implementation. So I will end the session. Actually, we had 2 activities, but there was no time. So it's okay. We will talk about it later. Okay? Thank you.
Now tell me your perspective on math. I think math is an interesting subject.
Yeah, now you came to know why I love math.
Mathematics is a powerful tool for global understanding and communication that organizes our lives and fills gaps.
Now, I would like to call upon Malishwari to propose vote of thanks. Until then, I Rakshita,
I, Samra,
signing off for today.
thank you.
Good afternoon all. As we come to the end of today's session, I am Malishwari from BSc second year. Take this opportunity to propose vote of thanks. I feel it a great honor and privilege to propose the vote of thanks on this occasion. Let me first of all thank by giving glory to the Almighty God for making today's session a resound success. First and foremost, I thank our Honorable Correspondent Sister Shyamala, respected Principal Sister Emmy, and our HOD Hemalata ma'am, and our beloved faculty for this opportunity, and for the valuable contribution, guidance, and encouragement in all our efforts. I also thank Pallavi ma'am and Srinivas sir for technological support. I owe special thanks to the non-teaching staff who worked hard to ensure that this occasion becomes a memorable success. Last but not the least, I thank you my friends for your cooperation in making this session a resound success. Once again,